Hey everyone. In this video I'm going to talk about the third form of mass collaboration, which is distributed data collection. And just briefly, we're going to go back to this overview of three different types of mass collaboration. And in comparison to the previous two, human computation and open call, distributed data collection involves projects where researchers enable participants to contribute new measurements of the world, essentially, right? So we're basically outsourcing measurement, for example, across geographic areas, and so on, right? So these types of projects, and I think a lot of them, a lot of those ideas could be particularly interesting for some of your projects, and some of you are interested in, for example, civil conflict and outcomes related to refugee displacement, for example. And so these distributed data collection efforts involve projects or involve data collections where people can be at locations where the researchers simply can't be, either because it's hard to get to that specific place, or because they're just you have to cover too large of an area that can't be covered by the researcher alone, right? So that's kind of describing the data collection at a scale that the researcher, or even a set of researchers with graduate assistants wouldn't be able to match, right? Of course, these are sometimes hard to separate from human computation tasks, but they oftentimes kind of involve directly kind of geographically dispersed data collection at a large scale, for example, right? And so rather than talking about the examples that are mentioned in the book or discussed in the book, I would say we will discuss a paper that is posted on a Canvas a while ago, which is Van der Wind and Humphreys 2016, crowd seeding in the Eastern Congo using cell phones to collect conflict events data in real time, which I think is a really cool example of such a distributed data collection effort. I posted the abstract here, which describes how they piloted a new data gathering system in the Democratic Republic of Congo, where villagers in a set of randomly selected communities report on events in real-time data via a short text message service. So this is one example where kind of distributed data collection allows allows to collect detailed data on something like conflicts on a much larger scale, regionally dispersed across a wide array of villages, for example, that would be impossible to cover for the researchers alone. And we'll talk about that in our Q&A session. So before we finish, I'm just going to kind of reiterate some of the pieces of advice that are mentioned in the Bit by Bit book on designing your own mass collaborations. The first aspect, the first piece of advice is to motivate your participants, right? So this can go in two different ways ultimately. Ideally, mass collaborations are easiest if people who participate voluntarily, because they ultimately enjoy the task, because they're ultimately, this can be if the task is designed as a game that is actually enjoyable to do. That is one example. Or, for example, the eBird case, where researchers are basically just tapping into a resource that already exists, because people already, kind of have the hobby of birding and, collect, essentially already kind of collect data about the birds that they view in their neighborhood or, in the wild. And so the participants are already motivated to kind of engage in that task anyhow, and you're just giving them a framework to collect the data in a way that can then be leveraged for researchers, right? Of course, not every research project is amenable to be designed as part, as a game or something like that. So motivating your participants can also be, or the can also occur by paying them through platforms like Amazon's Mechanical Turk or Crowdflower, where you can provide small payments for participants to ultimately perform your tasks. Right. The other important key that is kind of a deviation from especially the expert coding that we see in a lot of social science or previous social science research is this idea of leveraging heterogeneity, right? So, for example, when we talk about the scaling of party manifestos, this was done by experts, and the idea was that people have expert knowledge, and you can rely on a few experts who are very accurate in their assessments of given statements, for example, right? When you talk about mass collaboration, and especially in the context of these human collaboration, human computation tasks, there's usually more variability in expertise and skill, but the idea is to leverage that heterogeneity to have basically a lot of coders code the same task, so you have overlapping tasks for example, the statements in party platforms and so on, and then you can aggregate across responses to get still an accurate response, right? So the point here is not to kind of identify the most skilled or the most accurate person, but rather leverage the heterogeneity and through overlapping tasks, and then average or use, for example, average ratings, potentially using weighting methods and things like that, right? Thirdly, focus attention. So a lot of tasks, and there's one of the examples was the distributed data collection in the book, where researchers asked people to take pictures because the goal was to create 3D representations of cities, and based on community supplied pictures. And so there people were particularly tasked with like a reward system to take pictures of specific spots that weren't that were where more detail, where more information was needed, right? So kind of focusing attention of workers or participants on specific aspects where more coding or more scaling or more data collection is necessary is an important kind of aspect to improve your data collection or your mass collaboration data collection, right? Focusing on attention where you need more information. Fourth, enabling surprise, and that the idea here is to kind of enable the researcher's surprise in some sense, right? So oftentimes these kind of crowdsourced data collections might produce results or might produce findings that were not anticipated by the researchers, and the idea is to keep that in mind and design a mass collaboration in a way where you can still kind of provide the flexibility of your mass collaboration to kind of come up with results or with findings or with measures that you didn't necessarily anticipate before, right? So this example in the bit by bit chapter is the discussion of the Galaxy Zoo collaboration, where users ultimately found a different kind of type of galaxy that wasn't anticipated previously, right? And then lastly, of course, whenever it comes to mass collaborations, ethics are an important consideration. Not only when it comes to, for example, paying your MTurk workers enough money to complete your tasks. And in the next session next week, we'll talk much more about kind of ethics in the context of computational social science more general. So we'll spend a bunch of time talking about that as well. But that's all I have for you for this week. I'm looking forward to our Q&A session where we're going to talk about some of the papers that I mentioned briefly in these videos here. And then we're going to talk a little bit more about the third assignment as well.